So first of all, we should know what is mass storage structure. So magnetic disk, which is providing a bulk of secondary storage. That is the main usage of the disk. And drives rotate at 60 to 250 times per second. That's the initial stage. Okay. All the basic disk, the speeds which ranges from the 60 to 250 times per second. And then we need to consider some times for that. That is, some delay will be there for while we are going to read or write something onto the disk. First one is the positioning time. With the time to move this arm to a desired uh, cylinder. Okay, the diagram you will see next. And the time desired sector to rotate under the disk head. That is the rotational latency. The seek time and the rotational latency which is given. For the positioning, we are acquiring this. So a particular cylinder, if you are locating, that is a seek time. And for a particular sector, we are going to locate, it is a rotational latency. And then there will be a term called as a head crash. This is due to the disk which is disk head which is making contact with the disk surface. So if happened, there will be a crash. So that's bad, that we have to avoid. And the disk can be removable. So you know very well that which can be removable. And drive attached to a computer via IO bus, that is input output bus. Whatever the input output operation that we users we want to do, so that we can able to do with the connectivity only. The connectivity used for that one is the IO bus. IO bus, these are all the various types are there. Okay. This is, for example, ATA is advanced technology attachment. S is serial attached advanced technology attachment. Likewise, you have different types of buses which are all available. In the notes I have given you what actually the different types of buses which are available here. Okay. And here, one more thing is the disk controller, which is very important, which is having the full control over the IO operations that we can do with the disk. How we have the memory controller, all the storage and taking the data from that that we can able to control with the help of a memory controller. Similarly, all the IO operations with the disk will be controlled by the disk controller. And this is the moving head disk mechanism. So basically we have the ARM assembly. So in that we have the disk which are all available. How many disks we have? We have all those which are available as available one by one. And then first of all, if you are going to read anything on a particular disk means we have to keep the read write head in a particular place. Okay, for that we are requiring the arm to rotate the disk, and we are getting the cylindrical shape form here. So only with that arm we can able to position the particular track and the sector. So actually this circles here, they are called as tracks, and further it is divided here, no? So the each and every partition it is called as a sector. So first of all, we need to locate the which track we are going to read or write or perform the write operation, and then in that particular track we have to position the sector where actually we are going to start our read or a write operation. So each and every that disk which is called as a plater here. So that is going to be rotated. So the entire thing which is going to be rotated. So with the help of the arm, we can able to position the corresponding track in the sector. So this is the basic moving head disk mechanism. So the center one which is called as a spindle. And the magnetic disk, the platers which are ranged from 0.85 inch to 14 inches, which may vary. But in common usage, commercial purpose, we have 3.5, 2.5 and 1.8 inches. Okay. And the range of the pen drive, that is how much storage it is, from 30 GB to 3 terabytes. So that is available. And then the transfer rate is how much data we can able to transfer per second. That is either performing a read or a write. It is 6 GB. Effective transfer rate is 1 GB. If it is below that rate, automatically it will be a slow. So that they have mentioned here. And seek time is your the time delay to possession your particular track and sector, so that we can able to start our read or a write operation. So that ranges from 3 milliseconds to 12 milliseconds. So the common seek time is 9 milliseconds delay. It is on average, it is there. And the average seek time, which is measured 1/3 of tracks. Okay, it is depending upon the number of tracks available in your disk. So based upon that, the seek time which will be calculated. For this latency, actually for this formula, it is not working properly. I will check it and then tell you. Okay. So average latency is 1/2 of the latency. That is why they are telling it as a 0.5. It is a possibility that okay, one data may be the head position may be very nearer to the arm, so we can able to perform read or write immediately. But if you are going to track far away track or a sector, it will take some time. Delay time will be more, so that on an average they have taken it as 1/2 of latency. Okay. And then we have to find out the performance. So this performance we will see while we are going for that algorithm, disk scheduling algorithm. So this is your first commercial disk drive, which was manufactured in 1956, IBM Ramtech computer, which is including IBM Model 350 disk storage system, which is consisting of 7-bit characters. Nowadays it is normally 8 bits. 50 by 24 inch, that is the size of your platter, and the access time is which is equivalent to 1 second or less than 1 second. Now, when compared with current days disk, which is going to be very slower. And then we had a solid state disk. This is non-volatile. That's the main difference between your actual RAM and your disk. Your RAM memory, that is your main memory, which is volatile when you switch off the power. When we'll go for a non-volatile memory, permanently we can able to store it. One we have it as a hard drive, and another one is we can have the removable disk also. So here it is more reliable than the hard disk drives, and which is more expensive per megabytes. That is to store our data because of the shorter lifespan, and the capacity is also lesser. But it is much faster there. Okay, this which are faster, uh, even though it is expensive, which is faster, and the buses can be too slow. Suppose if your data size is going to be more, then automatically your I/O buses may be going down. Thus, it may be slow down. There are no moving parts here. That is why it is called as a solid state disk. The removable disks which are not coming under this category, here there is no moving parts, because there is no moving parts here, you don't have a seek time. So that's the thing. But the size of this is very minimum, and also which is very expensive. Okay, this is not actually your HDDs. This used, but the capacity which is lesser, and the drawback which is this is going to be very slower. But there is no seek time or rotational latency, because there is no moving parts here. So these are all the properties of the solid state disk, but it is not used much. And then next is the magnetic tape, actually, which was the older one to store larger data. The data which is of size larger, and the expense also very minimum. So this was widely used, magnetic tapes, secondary storage medium. which is permanently holding all the large quantities of data. But because it is secondary storage, the access time which is slower, the speed of it which is going to be very slower when compared with the disk. So the random access time, which is 1,000 times slower than the disk, so that we can compare the speed of the disk with the magnetic tape. Only advantages we can store the data size of larger, okay, data of a larger size. And the main purpose of magnetic tape is a backup, okay. And the infrequently used data we can able to keep some older data also.